Hello students, welcome to Young Cubs. Today we have brought yet another chapter. Okay, this time it's science. Okay, and the name of the chapter is Inside the Atom. Okay, so let's find out what's inside the atom. So children, there is one term, there are two terms in fact that I would like to elaborate on, or before we start the chapter, I would like to give you a basic fundamental idea about what an element is and what an ion is. So, what is an element, children? We've studied this in our previous years. An element is a substance which is absolutely pure and it is made up of the same particle, one and only one particle. So if I have a sheet of iron, okay, it is made up of iron and only iron, no iron compound like iron sulfide or iron oxide, nothing like that. It's only iron and only iron. When you have a substance or a material that is made up of only one and only one particle, it is known as an element. Okay, so let's find out what is an atom. It says an atom is the smallest particle. What is atom? It is the smallest particle, okay, of an element which retains its chemical identity. What does chemical identity mean, children? If you burn it or if you do something with it, if you fuse it or whatever changes you do in that particular particle, it will retain its properties. It will retain its basic characteristic, what it is. Okay? In all the physical and chemical changes. So, all in all, an atom, first thing, it is the smallest particle. Second thing, it retains its chemical identity always. And in all the physical and chemical changes it would go through. Okay, physical changes means, making it or involving it in a mixture. If I mix iron with sulfide, or if I just mix iron with anything else, okay, and if I take a magnet, very small particles of iron, and if I mix it with any powder, if I mix it with chalk powder, if I take a magnet and I just run it over through the chalk and iron mixture, okay, iron basic property, one of its basic property is magnetism. It quickly will cling to the magnet. And when it comes to chemical changes, something like rusting, okay, it will maintain that particular property when it comes in contact with air or in contact with water. Alright, so let's go through it once again. An atom is the smallest particle. Absolutely small. At that level of being microscopic, of an element which retains its chemical identity in all the physical and chemical changes. Yeah. So let me elaborate a little on smallest particle. So the word atom comes from a Greek word that means cannot be split. That means if I take a small iron block, I hammer it, and maybe I break it into several pieces. I hammer those several pieces as well. Okay, I make it into an absolute fine powder. After that also, that powder continuously, if I try breaking it down, I break it down to a level where that iron particle which was now visible is no longer visible. It has become microscopic. And even at a microscopic, if it further breaks down, there comes a point where it cannot be further divisible. So it cannot be further split. It cannot be further broken down. So that's small an iron. So an iron can be as, okay, if I just put a full stop, okay, atoms, there may be thousands and millions of ions in this small dot as well. So atom is basically that smallest particle which cannot be further broken down, which cannot be further split, which is indivisible. All right? So, the smallest particle of an element taking part in a chemical combination is an atom. What is a chemical combination? I take iron, I burn it in oxygen, okay? I take a piece of iron, or say I take a magnesium ribbon and I burn it in normal air. The air from the atmosphere will support the burning of magnesium, will get involved in the burning of magnesium, and I get magnesium oxide after burning a magnesium ribbon. So what is this? Can I get my magnesium back once it's burned? No, I cannot. So something which cannot be got back is one of the chemical properties an element or a molecule can go through. So once again, the smallest particle of an element. Smallest means something that cannot be further split up into, cannot be further divided. Okay, that takes part in a chemical combination. Okay, is an atom. Alright? So now, atoms and molecules are normally spoken about together. Okay, so when there is a particle, there is a single particle, okay, which is further cannot be divided, okay. But remember, an atom may or may not freely exist in open, in nature, in environment. Okay, simply because atoms could be highly reactive. यहाँ पर मैंने एक magnesium ribbon रखा. Okay, just magnesium, one atom of magnesium and one atom of oxygen. There could be a reaction, and suddenly that simple magnesium atom can have a reaction with oxygen. So atoms are highly reactive. Okay, that's the reason why they do not exist freely. Some do exist, some do not. So atoms may or may not exist freely, but molecules do. Why? Simply because two molecules, when come together, okay, may come in sync, may come in harmony, may come together simply to form a substance that will allow it to exist in nature. For example, if I take a hydrogen atom, it just doesn't want to survive alone. So what it does is there may be another hydrogen atom in nature. Obviously, if this one does not want to survive individually, this one, obviously being hydrogen again, will not want to survive individually. So what they do is they come close, they form a bond. They come together and they form a bond. And this is how they are happy, and this is how they exist in nature. Singly, they will not be seen in nature, but as a group, they may be. They may appear freely. They definitely appear freely in nature. Yes? Similarly, even oxygen, even nitrogen, okay, one oxygen atom will not exist freely. It needs a partner to exist. So they will always come as a unit. And when two atoms come as a unit, okay, it is known as a molecule. So it is not necessary that it cannot exist alone. For example, an atom of neon, an atom of argon. These are chemicals, these are gases, children. Okay, they exist freely. One alone neon atom can be found in nature. It may or it does not need a partner to exist. But something like hydrogen needs a partner, needs another atom like itself. A simple example is water. We get water only when there is a combination. Okay, so there may be two coming together, there may be a group of three which are likely to exist together, 4, 5 and so on. Even up to a level of 32 atoms combining together to form one unit or one molecule. Okay, so what do we understand by the term molecule now? So, children, you understood what are molecules? A group of atoms coming together, forming one unit is a molecule. Now, as we stated, there are some atoms which do not need company, which do not want another atom to form a unit. They are a unit in themselves. Okay, and they exist freely also. So they are atoms as well as molecules, right? So such molecules that can exist freely, okay, and they are single, made up of single atom. Okay, they are known as monoatomic. The word mono means one, single. Okay, examples of monoatomic molecules are neon, argon. Okay, then we have diatomic. Di means two. Dialogue, dicotyledons. Dicotyledonous seeds, remember? Okay, di means two. So, when molecules are made up of two atoms, okay, they are known as diatomic molecules. Examples are oxygen. See this 2 written below. Okay, that indicates that one molecule of oxygen or one molecule of hydrogen or one molecule of chlorine is made up of 2 atoms. Then we have triatomic molecules made up of 3 atoms. Perfect example is ozone. Remember, the ozone layer protects us from ultraviolet ozone. It is 3 oxygen molecules. And then more than 3 are generally categorized as polyatomic molecules. So, made up of 4 or more atoms. For example, sulfur. Sulfur is made up of 8 molecules. Alright, children. So you understand what are molecules? Okay? Alright. So, now we have gone through what is an atom. Okay? Something that cannot be split or it is indivisible in nature. We've studied about molecules, diatomic, polyatomic, triatomic, monoatomic. Okay, I had asked you guys to do some homework, okay, on differentiation between an atom and a molecule, and here it is. Okay, you could tally your points with mine. So, difference between atom and molecule. An atom is the smallest particle of an element. A molecule is the smallest particle of an element or a compound. So it diversifies. So element is restricted only to atoms. Compound can be are atoms and molecules. Okay. So if it is the same type of atoms combining together, it becomes an element. If different types of atoms come together, bond together, make a single unit, like hydrogen and oxygen, they are different atoms. When they bond together, okay, that time such a combination of atoms is known as a compound. So a molecule is the smallest particle of an element or compound. Atom does not exist in free state except in a noble gas. What is a noble gas? Argon, neon, and I'll tell you how they exist freely. We'll come to that. Okay? Whereas molecules definitely exist in a free state. Except some of the noble gases, other atoms are highly reactive. Okay, they react. If they're just lying anywhere and they are not in a stable state, I will explain what does a stable state mean. Okay, if they are not in a stable state, they will react with anything and everything in their environment. And molecules are less reactive. They react, but since they are more stable, they are already combined with somebody else to be happy, they don't react. Okay, atom does not have a chemical bond. Atoms in a molecule are held by chemical bonds. So atoms are just individual units. Individually they exist. But when in compounds, they need to come together, form one unit, and that's the reason why they are known as a molecule. Alright, children? Chale. Okay, let's find out. Alright. Here the names of the substances are given. Let's find out which is an atom and which is a molecule. Children, I want you to go ahead and tick mark these in your textbooks. Okay, and then we shall tally your answers. Alright, done children? Let's start. So, H2O, simple name, water. Is it an atom? Is it free in nature? No, it is not an atom. It is a molecule. And is it a single type of atom in the molecule? No, see this, it's H2O. So is it single? 2 atoms of hydrogen, 1 atom of oxygen. So it is not single. Different types of atoms in a molecule, and hence when different types of atoms combine, okay, it is known as a compound. When same types of atoms combine, it is known as an element. Oxygen, O2. Is it an atom? No, it's a combination of 2 atoms. 2 atoms combine together to form one molecule of oxygen. Hence, it is a molecule. It is a single type of atoms in the molecule. Only oxygen atoms. Hence, it is an element. Helium. Helium, do you see any number in and around it? Helium is just helium, 1 atom of helium. So, it is a monoatomic molecule as well as an atom. But we will still classify monoatomic molecules as an atom. It is a single type of atom in the molecule, and hence it is an element. Helium just doesn't combine. Hydrogen, H2. So is it an atom or a molecule? It is a molecule. Single type of atoms. Different types of atoms? No, it is an element. No, कोई और element join नहीं हुआ है यहाँ. Ammonia. Formula is NH3. So, it is an atom? No, it is a molecule. Single type of atoms? No, different types of atoms, and hence it will be classified as a compound. Nitrogen, N2. Is it an atom? No, it is a molecule, single type of atoms, and it will be an element. Methane, CH4. It's a molecule, different type of atoms, hence a compound. Argon, AR. It is an atom. Single type of atoms in the molecule, that monoatomic molecule hai, and hence it will be classified as an element. Neon, single. Atom same as argon. Chlorine, Cl2. Two atoms of chlorine combine to make a molecule. Single types of atom come together, hence it is an element. Okay? Is the difference between atom, molecule, single type of atoms forming elements, different type of atoms forming compounds. This concept is clear, children? Let's proceed. Alright. Let's go back to a little history of all these things. Okay, who were the people who studied so much of these chemistry and these atoms and how they combine. So here we have, see, India is a very, very intelligent country. We have our Vedas, Puranas, everything giving us answers to a lot of things. And people apparently all over the world have harped over it. Okay, so our Indian philosopher Kannad, somewhere in the 6th century BC, before Christ, stated that there is a limit to divide matter. That means after a point in time, something can not divide. It becomes indivisible. Okay, so it has a limit to divide matter into small particles. The indivisible particles that constitute the matter were named by Kannad Muni as Paramanu. The meaning of Parmanu is small particles. Who gave this name? Kannad Muni. Children, remember, these can come as fill in the blank. Quick fix. 1 mark seedha in your pocket. Okay, Kannad Muni in 6 BCE. He was an Indian philosopher. He named the word atom in Sanskrit or in Hindi as Parmanu. Okay, we have a movie also, John Abraham. Okay, he also stated that Parmanu is indestructible. Atoms can neither be created nor be destroyed. जितने हैं उतने ही रहेंगे. किसी को खत्म नहीं किया जा सकता. Okay, Greek philosophers Democritus in the 5th century BCE stated that matter is made up of small particles and these cannot be divided. Same theory. The smallest particle of matter was named by Democritus as atom. So, in Greek, okay, atom is known as atomos. Atomos se aaya atom, and which means cannot be split, cannot be cut. Alright, children? Here. We have Mr. Dalton. Dalton's atomic theory. Okay, I will show you a YouTube video on this where we get to know what Dalton has to say. All right. Now that was Dalton's atomic theory. Okay, let's read what your textbook has to say. So, Dalton's atomic theory, British scientist John Dalton put forth in 1803 AD his celebrated atomic theory. According to this theory, matter is made up of atoms and atoms are indivisible and indestructible. कहीं कहीं ये सुना हुआ लग रहा है. All atoms of an element are alike, while different elements have different atoms with different mass. Mass, vazan. Okay, children. So this is what we saw in the video. Every matter is made up of atoms. Atoms are indivisible, indestructible. 3 points. All atoms of an element are alike. Elements of different atoms have different mass. All right, everything is different for different different atoms. All right, we know that an atom is obviously anything is made up of something. अब atom भी है, we know it cannot be divided, but उसके अंदर भी तो कुछ होगा, इसलिए तो वो बोल रहा है कि उसके पास एक वजन है, it has mass. Simply mass means particles होना. Atom के अंदर भी particles होते हैं, okay? और वो particles कौन से होते हैं? Protons, which are positively charged, okay? Neutrons neutral होते हैं, plus भी है, minus भी है. Then we have electrons which are negatively charged. All right? चलिए, Thomson's plum pudding model of atom. Children, apparently जब ये पढ़ाई, जैसे कि आप मैथ सीखते हो, so you try one sum, you come up with a theory with an answer. If a friend is watching you do that sum, he's like, oh, you got it wrong, let me help you, let me use my brain. Then somebody puts in brain, you kind of give the basic fundamental. Then somebody identifies you went wrong. Then there is somebody who's like, both of you all are doing it wrong. And then there are 3-4 people, and then finally somebody has studied your matter. Then he's studied somebody else, and then he comes up with a conclusion of something, and then that thing becomes a theory and gets released. Okay, it gets released in media, public, to people, for students to study further. Alright, so this is what happened. Dalton ने कुछ theories propose की after his study. After Dalton, there was this gentleman Thomson. Okay, he came up. He thought, okay, fine, they are indestructible, but they are made up of some things. And what are those some things? Positively charged protons, neutrally charged neutrons, and negatively charged electrons. Okay, ये सब है, लेकिन दिखता कैसा है, अरेंजमेंट क्या है, where are the positively charged protons and the negatively charged, so ये है कैसा, let's look at it. He wanted to find the atomic structure. So here, before we read this, we can go for another video too.
In this module, you will learn about Thomson's atomic model. Are the charged particles arranged in any particular manner? Are the charged particles spread throughout the atom? Or are they concentrated in one place? To answer these questions, let's go back in time. Dalton's atomic theory stated that an atom was indivisible and indestructible. However, in 1886, Goldstein came upon positively charged radiations in a gas discharge, which he termed as gamma rays. These radiations led to the discovery of the proton. The mass of a proton was about 2,000 times that of an electron, and it carried a positive charge. Around the year 1900, J.J. Thomson conducted experiments on the beams of particles inside a glass tube called a cathode ray tube. He found that the particles were attracted to the positive terminal of the tube. Thomson concluded that the particles must be negatively charged and called these particles electrons. An electron has a negligible mass and has a charge of -1. These discoveries made the scientists believe that an atom was divisible and made up of electrons and protons. What they didn't know at the time was how these electrons and protons were arranged within an atom. They tried to understand this arrangement through various experiments. J.J. Thomson was the first to put forward a model to explain the structure of an atom. In his model, Thomson compared an atom to a Christmas pudding. The electrons were like the raisins in the pudding, and the pudding itself was like the positively charged particles. This can also be explained through the example of a watermelon. The positive charge in the atom is spread all over like the red, fleshy part of the watermelon, while the electrons are embedded into the atoms like the seeds of the watermelon. The oppositely charged particles are held together by electrical force of attraction. Thomson concluded that an atom consists of a positively charged sphere with electrons set within the sphere. An atom is electrically neutral as the positive and negative charges within it are equal. As per Thomson's conclusion, the electrons were embedded in a sphere of positive charge. This conclusion, however, was incorrect. Thomson asserted that the positive charge spread through the atom held the negatively charged electrons due to electrical forces. This assertion aimed to explain many experimental observations. In this module, you have learnt that atoms are made of charged particles. According to Thomson's model, an atom is a positively charged sphere with electrons set within it. An atom is electrically neutral. Shortcomings of Thomson's model are his incorrect assumptions. Electrons are embedded in positive charge. Positive charge in the atom holds the negatively charged electrons.
So what does Thomson have to say? He had this plum pudding model, where the plum pudding model of an atom put forth by Thomson in the year 1904 is the first model of atomic structure. I told you, people were talking about it had positive charge and this charge and that charge. But kahan milta hai? How is it structured? He put forth the first structure. Okay. According to this model, the positive charge is distributed all throughout. Like if you've seen a watermelon or you've seen a cake. Okay. Let's talk about a plum pudding. Okay. If you've seen a pudding, everything is positively charged. And uske upar kaise kishmish, badam ya fruits डालते हैं. Okay. Those were the negatively charged toppings on it. Okay, this is how he assumed that the structure of an atom looked like. So according to this model, the positively charged, the positive charge is distributed throughout the atom and the negatively charged electrons are embedded in it. The distributed positive charge is balanced by the negative charge. So both are equal. Jitna positively charged distribution है उतना ही negatively charged particles भी है. So positively charged protons were equal to the negatively charged electrons. Okay. Therefore the atom becomes electrically neutral. देखा ना, plus 10 and minus 10 nullify, answer is 0. So उतने ही plus charges का embedding था, उतने ही जितने प्लस चार्जेस थे उतने ही नेगेटिवली चार्ज इलेक्ट्रॉन्स भी थे. सो इट नलिफाइज, इट बिकम्स न्यूट्रल. 0 मीन्स न्यूट्रल, बैलेंस्ड. ओके, सो दैट्स हाउ एटम ओवरऑल इज न्यूट्रल. ओके, नाउ दिस इज J.J. Thomson and this is how the structure of this can come for drawing. 2 marks. Circle बनाना है, बाहर प्लस साइन, अंदर सर्कल में माइनस साइन. Okay, this depicts the plum pudding method or plum pudding model of atom. All right. So now after Thomson, we had Rutherford coming up with his theory. Let's look at another video. We understand this to understand this better. Rutherford's nuclear model theory. Alright children, let's look at this video now.
The plum pudding model of an atom was one of the most widely accepted models all over the world for understanding the structure of the atom. However, several experiments performed by scientists to study the atomic structure showed astonishingly different results. They were contradicting the plum pudding model. This led many scientists all over the globe to reconsider the structure of an atom and study it again. Around the year 1911, a British physicist, Ernst Rutherford, carried out the famous gold foil experiment. He did this to understand the structure of an atom. The experiment was carried out by Rutherford along with Hans Geiger and Ernest Marsden. The experiment he performed was a breakthrough in the field of chemistry which helped him understand the structure of an atom in a more accurate manner. This is how the setup of his experiment looked like. As we can see here, he used a source of alpha particles locked in a lead container with a very small slit. This ensured that the alpha particles only came out through a small opening and travelled in a straight line. But why did he select alpha particles in the first place? Well, the alpha particles were having high energy and were heavier as well. So if we say the atom is like a pudding of positively charged particles with electrons embedded in it, then the particles will pass straight through it. This is obvious because the heavier particles will pierce through the lighter pudding structure of the atom and pass through it. This is what Rutherford thought. For this reason, their greater mass and energy compared to the protons made him choose alpha particles for the experiment. Next, he used a very thin gold foil on which the alpha particles would bombard. Why did he choose a gold foil? Well, a really thin gold foil was estimated to contain approximately 1000 atoms. Lesser the atoms, more convenient the experiment would be. Lastly, are we able to locate the circular band with a gap here? What could this be? Well, this is a screen. A fluorescent screen that would help us detect the radiation. That means the screen will glow or emit fluorescent light whenever alpha particles will hit it. So this is how the track of alpha particles can be traced. Now we're all set to understand how the experiment worked. The alpha particles were emitted from the element present in this box. These directly hit the gold foil. Now what should happen ideally? As we know, the Thomson's model suggested that an atom is a sphere of positive charge with negative electrons embedded inside it. That means it is expected that the alpha particles will pass right through the atoms and hit the detector straight. And why so? Because the mass of alpha particles is heavier than the mass of positive charges. That means they should directly hit the atom and move ahead through it. Only a very small deviation would probably be acceptable in this case. But is this what he observed? Not really. He was astonished to get unexpected results. What results did he get? He found that most of the fast-moving alpha particles passed straight through the foil and hit the detector. However, some particles got deflected by small angles. And lastly, to his astonishment, few alpha particles also rebounded. Now, how can this be possible? These three observations made Rutherford think that the plum pudding model is not really correct. Based on the conclusions he had, he put forward the new hypothesis explaining the structure of atoms. What were his conclusions? Let us have a look at the conclusions by Rutherford, followed by the new atomic model put forth by him in the next video. Rutherford's gold foil experiment gave him interesting results. What results did he get, by the way? Let me recall them for you. He found that most of the fast-moving alpha particles passed straight through the foil and hit the detector. However, some particles got deflected by small angles. And lastly, to his astonishment, few alpha particles also rebounded. Now, how can this be possible? These three observations made Rutherford think that the plum pudding model is not really correct. Let us take a simplified example to understand the inferences first. Let us imagine that we have a ball made up of cotton. The cotton in the ball is very sparsely distributed and has an extremely tiny circle or sphere located at the center. This sphere is quite hard and dense. So hard that it can even resist a bullet shot against it. Now, what will happen if you shoot many bullets across this cotton ball? Most of them will travel straight through the cotton surface. What will happen if a bullet hits the edge of the central heavy mass? In this case, the bullet will slightly change their path and get deviated. So looking at the size of the central mass, it's obvious that only some of the bullets will get deviated. Lastly, what happens when a bullet hits the center directly? Needless to say, it will bounce back, because we know that the central dense mass is too hard for the bullet to pass through. So very few bullets will bounce back. This is analogous to what Rutherford had inferred about the atomic structure. His first conclusion was that most of the space inside an atom is empty. This is because most of the alpha particles could easily pass through the atoms and hit the detector straight. Now, if most of the space is empty inside an atom, then where is the positive charge located? Well, that's the second conclusion. The positive charge is compactly packed in a tiny entity. This occupies an extremely small space inside the atom. Now, why did he think so? Let's go back to our cotton ball and bullet example. Can you recall the second and the third case? Yes, the bullets get deviated on hitting the tiny sphere of the edge, and they will rebound when they hit the center. Same explanation holds true for this. A few alpha particles get deviated. That means there is a possibility that these hit the edge of the positive center. Yes, and one more possibility is that they get deviated because the positive center
तब कंप्यूटर टेस्ट ही नहीं कर पाया फार्मर का पास कमीशन वीकनेस को बोला था इसने सफल कमीशन में आके तो सभी पास हो जाते हैं अब ठीक पड़ी है फिर आप बात करके निकाल मैं भी नहीं
पूरा रूम तेरा क्यों फीमेल के साथ नहीं रहे
सुबह कैसा भी सोते नजर आती है फिर वो गलत थॉट्स लगते हैं हमारे मतलब दोस्त की गर्लफ्रेंड है तो ऐसे थॉट्स नहीं लाते ऐसे करके तो शायद कर ले शायद
Let's have a look at the hypothesis put forward by him. Firstly, there's a positively charged center in an atom called nucleus. Nearly all the mass of an atom resides in the nucleus. Secondly, the electrons revolve around the nucleus in circular paths. Thirdly, the size of the nucleus is very small compared to the size of an atom. However, theoretically, there were many flaws in the hypothesis. Let's have a look at the drawbacks in Rutherford's hypothesis in the next video. Also, we will have a look at the explanation of atomic structure by another scientist named Niels Bohr in the next video. Why does bond formation take place? Can you give me?
All right. So children, what did the video say is now just written in your textbook. Yeah, the video is more elaborate and your textbook says it in a very concise manner. It says Rutherford took a very thin gold foil. We saw that gold foil thickness of 10 raised to minus 1. 10 raised to minus 1 is 0.1 mm and bombarded it with positively charged alpha particles. What are alpha particles, children? Alpha particles are the radiations that are positively charged. Remember, they are radiations. Heard about the term radiations, mobile radiations and all that? So these are also radiations. Rays come out of it and positively charged rays come out of it. Okay, so alpha particles emitted by a radioactive element. Radioactive means something that gives out light. Okay. He observed the path of alpha particles by means of a fluorescent screen. So you know that circle that they had made? That was of a fluorescent material so that the light, apparently the rays could shine in them and they could find out the path of the radiations. Okay, so fluorescent screen around the gold foil. It was expected that the alpha particles would get reflected from the gold. Okay, so they expected a reflection, okay, from the gold foil if the positively charged mass were evenly distributed inside the atoms. So what did Thomson put across? That there was an atmosphere and everything was positively charged and the negatively charged particles were embedded. But, and so Rutherford thought that these particles, the positively charged particles, they will reflect. Okay, they will go there and they will reflect, they will deviate, okay, they will reflect, all of them. Okay, from the gold foil if the positively charged mass were evenly distributed inside the atoms. Unexpectedly, most of the rays went straight, so there was no reflection, no change in direction. It just went through and through the gold foil. Ideally it should have gone straight and reflected because positively there were two like charges. Alpha particles were positively charged and the atoms were also positive. So like poles attract, like poles repel. So like charges would repel, they would reflect. But these particles went straight through and through the gold foil. Okay. A small number of alpha particles got deflected, only very small, okay, from the original path through a small angle. A still smaller number of particles got deflected through a larger angle, and surprisingly, one alpha particle out of 20,000 bounced back in the direction opposite to the original path. So there was a circular thing and there was a gold foil. It went through, and then the path was changed. Ideally, it should have hit the gold foil and deflected. But it through and through gaya. Okay, and it was quite unexpected because they were harping or they were all believing Thomson's theory. So if you see, यहाँ से alpha particles shoot away from a very small point. From a very small point, they went here. Most of them went straight. Okay, very few, they were almost passed. Very few at a very small angle deflected. बहुत छोटा angle था. And there was only 2 or 1 of them which had a wider angle of deflection. This was very, very contradictory. Very, very different from what they had thought. So that's where it came up that maybe Thomson's theory was incorrect. The large number of the alpha particles that went straight through the foil indicates that there was no obstacle in their path. There were no positively charged particles in the as an atmosphere, or as everything was not positive. Okay, indicates that there was no obstacle in the path. It meant that there must be mainly an empty space inside the atoms in the solid gold foil. The small number of alpha particles that get deflected through a small or a big angle must have faced an obstacle in their path. So very small obstacle must have been there. It meant that the positively charged and the heavy path causing obstruction would be in the center. So it must have been in the center. That's where this radiation has reached the center, and we know that the center of an atom is positively charged. So this is positively charged. So they have repelled and gone. Okay, they've got deflected. Okay, causing obstruction which is at the center. From this, Rutherford put forth a nuclear model for atom as follows. So this diagram can also come. Moreover, you may be asked to draw this one, scattering experiment. This is what you will draw for scattering experiment. Okay. So, inference means conclusion. क्या पता चलता है? Result क्या हुआ? बताइए. Okay. there is a positively charged nucleus. Nucleus means the center of the atoms is positively charged. Okay? Almost the entire mass of the atom is concentrated in the middle. तो जो कुछ भी है middle में है, that's how we did they come to know, because कोई obstruction नहीं था. It went through and through. Okay, negatively charged particles called electrons revolved around the nucleus. The total negative charge on all the electrons is equal to the positive charge. So जितने positively charged particles है एक atom में, उतने ही negatively charged particles हैं उस atom में. So atom consists of positive, that is proton, negative, that is electron, and दोनों equal है. And that's the reason why, remember, the atom is neutral. And that's the reason why atoms don't even react. Okay? As the opposite charges are balanced, the atom is electrically neutral. There is an empty space between the revolving electrons and the atomic nucleus. Chalo. With this, let's draw what he's trying to tell us. So, as per what these statements are, okay, this is a positively there is a nucleus which is positively charged. Outside this is empty space. And so this space is empty. This space is empty. And we have negatively charged electrons moving around the center portion, which is also called as the nucleus. Okay? And since बीच में ही सारे positively charged है, तो सारा mass, सारा वजन सेंटर में है. Alright? And also जितने पॉजिटिव चार्जेस अंदर हैं उतने ही नेगेटिव चार्जेस बाहर हैं. Okay? These are the 4 things that these are the 5 things that I could conclude, and this is how I have kind of made a rough diagram from the inferences. Okay? But they're studying, they're finding out things, they are assuming things. कितनी बार assumptions wrong भी तो होती हैं. So इस मॉडल का भी shortcomings थे, कुछ wrong हो गया. As established law of physics, an electrically charged body is revolving in a circular orbit. The electrically charged body is revolving around. There's a positively charged nucleus, and around the nucleus there is something revolving around the nucleus in orbits. Okay? So body is revolving in a circular orbit, its energy decreases. So electrons की energy decrease हो रही है. According to this law, the atom described in Rutherford's model turns out to be unstable. तो energy कम होती जा रही है तो खत्म भी होगी. कुछ पता नहीं, he just said it's decreasing. उसके बाद क्या खत्म हो जाती है, जीरो हो जाती है, कुछ पता नहीं, कुछ बता नहीं. तो उसकी theory short पड़ गई. In reality, however, all atoms except radioactive atoms are stable. This shortcoming of Rutherford's atomic model was removed by the atomic model put forth by Niels Bohr in the year 1913. So, अब Thomson, Thomson, Rutherford के बाद now Niels Bohr worked more upon, understood more of their theory, and he started his work after that. Alright, now let's again look at a video from Niels Bohr.
Rutherford's atomic model was quite commendable when it came to explaining the structure of atoms. However, it was not very appropriate theoretically. And why are we saying so? We know that any charged object which revolves in a circular motion gains acceleration gradually. Similarly, if the electron is moving fast in a circular path, then it will also gain acceleration. And on gaining acceleration, it's bound to liberate energy in some form. Now, if it continuously keeps radiating energy, then ultimately all the energy of the electron will get over and it will fall into the nucleus. This would result in high instability of the atom. But wait a second, all these things do not happen in an atom. And how do we know this? Because in nature, all the atoms are stable. That means the hypothesis put forth by Rutherford was also incorrect? Not really. The hypothesis just needed slight modifications. These were made by the next legendary scientist in our list called Niels Bohr. He made a few additional explanations to describe the atomic structure. The postulates put forward by Niels Bohr were as follows. Firstly, only certain special orbits called discrete orbits of electrons are allowed inside the atom. Secondly, while revolving in these discrete orbits, the electrons do not radiate energy. Now these points definitely tell us why an atom is so stable. But what exactly are these paths or orbits in which the electrons revolve around the nucleus? Let's understand with an example. Do you know how our solar system is? Yes, it appears somewhat like this. Now here, the sun is stationary at the center while the planets revolve around it. But have you noticed that the planets always revolve in fixed paths? We never find any planet jumping to a different path all of a sudden, right? They always encircle the sun in defined paths. In a similar way, we have the atomic structure. The nucleus acts like the sun located at the center, and the electrons are like planets which revolve in fixed, defined orbitals. These electron orbitals are referred to as shells or energy levels. Now the name energy levels gets us to an important concept. Niels Bohr suggested that the electrons revolving in these orbitals do not radiate energy. Now, this is justified when we use the term energy levels, because it indicates that each shell has got a defined energy level. That means when the electrons revolve in these shells, they do not liberate any form of energy. And how do we name these shells to indicate their position? It's simple. Beginning from the one near the nucleus, we name them as the K shell, L shell, M shell, N shell, and so on. Yes, K, L, M, N, and so on. And what if we want to number them? In that case, we use the letter N in lowercase and write them as N equals 1, N equals 2, N equals 3, and so on, beginning from the one next to the nucleus. So we can name them alphabetically, or we can even number them. With all these theories and points known, do we now know the structure of a typical atom completely? The nucleus contains positive protons and the electrons revolving around in fixed orbitals. Is that how an atom is structured? Not really. We still have one more subatomic particle left. And what and where could it be? Let's find that out. It was around the year 1932 when a famous English physicist, Sir James Chadwick, found the third subatomic particle. He found that the particle had a mass almost equivalent to that of the proton. And what about its charge? Astonishingly, it had no charge. Yes, the particle was neutral. The particle was later named as neutron, denoted by the letter N. Thus, now we have the complete design of an atom. In the center lies the nucleus having positively charged protons and neutral neutrons, while the negatively charged electrons revolve in fixed orbitals around the nucleus. But how exactly are the electrons distributed in the respective orbitals? Is there a way to find out the maximum number of electrons that one orbital can contain? Or is it that the electrons are randomly scattered in the orbitals? Let's find out the answers to these questions in our upcoming video.
Alright. Bohr's stable orbit atomic model, which was performed or formed in 1913. Now the electrons revolving around the atomic nucleus. The electrons are revolving around the atomic nucleus. Children, what does the atomic nucleus have? It has positively charged protons and neutrally charged neutrons or neutral neutrons. Okay? So the electrons are revolving around the atomic nucleus. Children, what is the charge of the nucleus? Since nucleus has protons and neutrons which are neutral, the overall charge of the nucleus, the atomic nucleus, is positive. Alright, which is then balanced by the electrons, the same number of electrons revolving around it, lie in the concentric circular orbits at certain distance from the nucleus. So, what does Bohr have to say? Bohr has to say that there is a centrally located atomic nucleus having protons and neutrons, okay, and a little away from the nucleus starts the placement of negatively charged electrons in concentric circular orbits, and they have a certain distance from the atomic nucleus, from the center. Okay, the energy of an electron is constant. Now remember, what did Rutherford say? That the energy keeps decreasing? No, he states that the electron energy is constant. It does not fade away. It does not keep decreasing while it is in a particular orbit. When an electron jumps from an inner orbit to outer orbit, so when from an inner orbit, from this orbit, if the nucleus jumps to an outer orbit, it absorbs energy. It takes energy equal to the difference of its energy level. And when it jumps from the outer to the inner orbit, it emits energy. It gives out energy. Look at this. From inside to outside, from inside orbit to an outer orbit, it absorbs. And from an outside orbit to an inside orbit, it emits. Absorbs when inner to outer and emits from outer to inner, equal to the difference of its energy levels. He talks. This is little more complicated. Alright, now let's come to the fundamental structure. Children, these nucleus, protons, no, not nucleus, but protons, neutrons, electrons are known as the subatomic particles. Positively charged protons, electrons, and neutrons. These are particles inside the atom which constitute the atom. So they are collectively called as subatomic particles. So what is the nucleus? The center or the central part of an atom. And what did I just state? It is positively charged. Okay. It's not very easy to break the nucleus and bring out the inner particles. It's not easy to bring out the protons and the neutrons from the nucleus. Okay. Next, what does the nucleus contain? The nucleus contains positively charged protons. Now this is inside the nucleus. Neutrons, they are neutral. Neutral particles. Okay. They are also inside the nucleus. Remember, children, both the protons and the neutrons form the mass. Mass of an atom. From the mass of an atom, and the mass of an atom is denoted by A. Alright, together the protons and neutrons are also called as the nucleons. Protons and neutrons together are known as nucleons. Alright, then we have the shells. What are they? The orbits around the nucleus, the orbit around which, around which they are the fixed path for the Yes, children. The orbits around the nucleus, they are the fixed path for the electrons to revolve. So, if you have an atom, where should I draw? Okay, if this is your atom, this is your nucleus. Okay. This is the first part called the shell. It is named as K shell. Second one is named as L. Third one will be named as M, and so on. So these shells are named. Okay. The closest one, the closest shell to the nucleus is named K shell. Then it's L shell. M shell, and so on. Yes, children, remember, they don't start with ABC, they don't start with XYZ. It starts from middle, it starts from K shell. The nearest one to the nucleus is K, then L, then M, and so on. Alright, then we have electrons. What are electrons? Electrons are the negatively charged particles. They revolve round the central nucleus in these orbits. Okay, children? Now these electrons are outside the nucleus, and their mass is negligible. Okay? Go through what we've written. Please go through what we've written till now. If you don't understand anything, please tell me. So now, we know, so let me draw the structure over here again. This is your centrally located nucleus. Okay. First orbit known as the K shell. Second orbit L. Third one M, and so on. Alright. So we know this. Now we know the names. Now children, what do you think? How are the electrons placed? See, we know number of protons is equal to number of electrons. We know that. जितने प्रोटॉन्स हैं न्यूक्लियस के अंदर उतने ही इलेक्ट्रॉन्स हैं न्यूक्लियस के बाहर. तभी तो एक एटम न्यूट्रल होता है. ओवरऑल द चार्ज ऑफ एन एटम इज न्यूट्रल. राइट. सो नाउ बट प्लेसमेंट क्या है? फर्स्ट ऑर्बिट में ही तो फर्स्ट ऑर्बिट में सारे इलेक्ट्रॉन्स डाल देते. अगर एक एटम है जैसे सोडियम, या लेट्स टेक सोडियम. ओके, सोडियम का एटॉमिक नंबर इज 11. सो इफ दिस इज an atom of sodium, it has plus 11 in the middle. Okay, फर्स्ट ऑर्बिट के शेल है तो 1 2 3 4 5 6 7 8 9 10 11 डाल देते. ये KLM की क्या जरूरत है? Why are we making it complicated? What happens is न्यूट्रल, वो जो वेट डिस्ट्रीब्यूशन है, वेट तो खैर होता ही नहीं है, वेट डिस्ट्रीब्यूशन तो होता नहीं, बट एवरीथिंग कैन नॉट बी इन द सेंटर ऑफ द एटम, राइट? सो पार्टिकल्स एंड एनी विच वे, हाउ कैन यू से दैट सन बीच में है तो मर्क्यूरी, वीनस, अर्थ, मार्स, जुपिटर, सैटर्न, यूरेनस, नेपट्यून सारे के सारे मर्क्यूरी के फर्स्ट ऑर्बिट में ही घूमते रहे? No, it doesn't work that way. So that's how since सारे planets एक ही साथ एक ही ऑर्बिट में लाइन में नहीं चल सकते, वैसे ही हमारे इलेक्ट्रॉन्स का भी है. So now तो फिर कैसा है? फर्स्ट शेल में कितने हैं, सेकेंड शेल में कितने हैं? How do we find that out? Or how is it placed? All right. So let me go ahead and take a sodium cell. Sodium का molecular formula क्या है? Na. Correct? Let me write it up. Okay, now children, ऐसा है ना कि एक फॉर्मूला है. कौन सा फॉर्मूला? फॉर्मूला इज 2n². 2 तो समझ में आता है. n क्या है? Where n is equal to the number of the shell. ओके. नाउ सोडियम सेल लेते हैं. ये हो गया हमारा न्यूक्लियस. ओके ओके, दिस इज आवर न्यूक्लियस. ओके, इसमें क्या है? प्लस, क्योंकि इसमें नंबर ऑफ प्रोटॉन्स कितने हैं? +11. ओके, इसका प्रोटॉन्स कितने हैं? 11. दैट मीन्स इट हैज अ चार्ज ऑफ प्लस. ओके, तो जितने प्रोटॉन्स हैं उतने ही इलेक्ट्रॉन्स भी होंगे, विच इज इक्वल टू -11. करेक्ट. अब ये 11 कैसे करें? लुक एट दिस फॉर्मूला 2n². 2 इंटू n क्या होता है? नंबर ऑफ द शेल. अगर मैं फर्स्ट शेल बना रही हूं, के शेल बना रही हूं, तो ये मेरा फर्स्ट शेल हुआ. एंड n², 2 इंटू 1 इंटू 1 कितने हो गए? 2. यस चिल्ड्रन, यस और नो? कितने हैं इलेक्ट्रॉन्स? कितना आंसर आया? 2. तो फर्स्ट शेल में 2 इलेक्ट्रॉन्स होंगे. यस चिल्ड्रन. बिल्कुल भी नहीं दिख रहा. ओके, अब ये 11 में से 2 चले गए, 2 माइनस. अब कितना बचा? -9. करेक्ट. अब देखते हैं, -9 बचे हैं. फॉर्मूला क्या है? 2 इंटू n². अब सेकेंड शेल की जरूरत है क्योंकि 9 इलेक्ट्रॉन्स पे जाएंगे कहां? ओके, सो मेरे सेकेंड शेल में n depicts my second shell. 2 into 2, my answer is 8. So second shell में कितने जाएंगे? So I will construct a second shell and ये 1 2 3 4 5 6 7 8. अब 9 में से कितने गए? 8. बचा 1. अब मुझे थर्ड शेल की भी जरूरत होगी बिकॉज 1 इलेक्ट्रॉन बचा है, वो कहां जाएगा? सो माय थर्ड, तो एक थर्ड शेल भी कंस्ट्रक्ट होगा. अब थर्ड शेल भी, क्योंकि 1 बचा ना. ओके, ये रहा मेरा 1. बट मैम आपने कहा कि 2n² के हिसाब से नंबर ऑफ इलेक्ट्रॉन्स होते हैं, बट सोडियम जो है उसका एटॉमिक नंबर ही 11 है. कहां से लाऊं भरने के लिए? सो अगर है नहीं, इलेक्ट्रॉन्स ही नहीं है, I cannot bring, right? I can bring, but I will tell you later how. But as of now, originally इसके पास 11 है तो इनको ऐसे ही सेट होना है. बट अदरवाइज अगर ये और एक बड़ा सेल होता और एक बड़ा एटम होता, नॉट सेल, और एक बड़ा एटम होता है, तो थर्ड शेल का क्या इक्वेशन होता है? थर्ड शेल में कितने इलेक्ट्रॉन्स होते? लेट्स फाइंड आउट. 2n² हमारा फॉर्मूला है. सो 2n² इज इक्वल टू 2. ये मेरा थर्ड शेल है, तो नंबर 3 का स्क्वायर, 2 इंटू 3 इंटू 3, 3 3 9, 9 2 18. तो इसकी कैपेसिटी, थर्ड शेल की कैपेसिटी कितनी होती? 18 इलेक्ट्रॉन्स की कैपेसिटी होती. सो बेसिकली दिस फॉर्मूला 2n² will tell you what is the capacity of each shell. What will this tell you? What will this formula tell you? The capacity of each shell. इससे कम हो सकते हैं उस शेल में, डिपेंडिंग अपॉन विच एटम यू टेक, बट ओवरऑल इट कैन नॉट एक्सीड. एक शेल में 8 की कैपेसिटी है तो वो 8 ही लेंगे, इट कैन नॉट एक्सीड. अगर उससे ज्यादा है तो एक नया ऑर्बिट, एक नया शेल ऑटोमेटिकली कंस्ट्रक्ट होता है, ऑटोमेटिकली बन जाता है, and there is a new electron, the remaining electron gets placed in the newer shell. All right children, कितने ही shells बना लो, कि कितने ही shells, K shell, L, M, N, O, P, Q, R, whatever, आप जानते हो कि ये फॉर्मूला के हिसाब से the number of electrons will be placed. Okay, for example, this has 18. The next one we'll find out. Chale, let's find that out. Okay, so L shell, second shell है. So 2 into 2 का स्क्वायर, 2 का स्क्वायर कितना होता है? 4. 2 का स्क्वायर होता है 4. 4 into 2, 8. M शेल आपका थर्ड, N शेल आपका फोर्थ, तो 2 into 3 स्क्वायर, 3 3 9, 9 2 18. तो थर्ड शेल की कैपेसिटी कितनी है? 18. उससे कम हो सकते हैं, उससे ज्यादा ये होल्ड नहीं कर पाएगा. ठीक है. फोर्थ शेल 2 into 4 स्क्वायर, 4 4 16, 16 2 32. And so on. So ये फॉर्मूला के हिसाब से you will be able to estimate, or you will be able to know there are how many electrons in that particular shell. All right, and then we know अंदर जाता है तो एनर्जी रिलीज करता है, बाहर आता है तो एनर्जी अब्सॉर्ब करता है. बाहर क्या आता है? इलेक्ट्रॉन्स बाहर आते हैं. We just studied in Bohr's theory, right? अब कितने भी शेल्स हो, अगर फॉर एग्जाम्पल KLMN O शेल भी होता, बट O शेल आपका लास्ट शेल होता, कम वॉट में, लास्ट शेल के लिए ये जो फॉर्मूला है ये काम नहीं करता है. कम वॉट में लास्ट शेल में हमेशा 8 इलेक्ट्रॉन्स ही होंगे. ये भले K में 2 है, L में 8 है, M में 18 है, N में 32. If O is the last shell, if O is the last shell, how many electrons will be present? 8. Always. Last shell will always have 8 electrons. 8 electrons will always have, मतलब 8 electrons की capacity. It will always have a capacity of 8 electrons. Not necessary that it will have 8 electrons. We just saw the sodium atom. उसमें लास्ट शेल में एक ही थे. वो लास्ट शेल है, वो अपने किसी और से खींच के 7 और लाके इसको कंप्लीट कर सकता है. आई विल टेल यू हाउ. बट कैपेसिटी उसकी 8 से ज्यादा की नहीं है. बाकियों की कैसे इतनी ज्यादा है, बट लास्ट शेल की सिर्फ 8 की कैपेसिटी है. जब अंदर का एक शेल भर जाता है तब बाकी के शेल्स को अकोमोडेट करने के लिए एक और बनता है. ओके, दो शेल्स की दो इलेक्ट्रॉन्स की ही कैपेसिटी है फर्स्ट शेल में. अगर तीसरा इलेक्ट्रॉन है तब जाके न्यू शेल बनेगा एंड देन it will be placed in the next shell. Once 8 completed, it cannot hold more, a newer one will come. Cannot hold more than 18, a newer one will come. Cannot hold more than 32, a newer one will come. However, if this is the last one, it will have only a capacity of 8. Children, are we understanding? The last shell, जिसकी capacity 8 से ज्यादा की नहीं है, that shell is known as the valent shell. Okay, and last shell में जितने electrons हैं, last shell में जितने electrons हैं, those are known as valent electrons. Okay, now these valent electrons can jump to other cells or call for newer cells to fulfill their capacity. अगर सोडियम में, we just now saw, अगर सोडियम में last shell या valent shell में if there is only 1 electron, it can call 7 more or it wants 7 more to come in so that it can satisfy itself, उसमें कुछ कमी ना रहे, right? And it will attain stability. If an electron, if there are lesser electrons than 8, that means the atom is not stable, it is unstable, it will react. But however, if the outer shell fulfills its capacity of 8 electrons, okay, it will become stable, it will become unreactive. And that's the reason why everywhere that we read in the previous slide that noble gases do not react simply because इनका outer shell complete है. 8 आ गए, घर भर गया, ना किसी की जरूरत है क्योंकि हम उसको accommodate नहीं कर सकते, ना हमको देना, हम क्यों कमियां लाएं अपने अंदर. So they become unreactive. So remember children, noble gases are unreactive simply because their outer shell fulfills their capacity. Okay. Now children, if first shell की capacity कितनी है? 2. उसके beyond अगर shell electrons हुए, so a new orbit is born. Yes. So once the first shell attains or gets 2 electrons, you can say that it has attained duplet state. It has attained duplet state. Alright? Once an orbit, the outer orbit, the valent orbit, has attained 8 electrons, we call it wants to attain 8 electrons, and if the outer shell में सारे 8 आ जाते हैं, so we say that it has attained its octet state. Alright children, is that much clear? Chalo, let's look at the first 20 elements of the periodic table. Or let's understand what is this. Okay, first in the list is hydrogen. Okay, why is hydrogen first in the list, children? This is how a hydrogen atom will look. Somewhat. What does this mean? Hydrogen has one proton. So that means its atomic number is 1. What is atomic number, children? Atomic number, which is denoted by atomic, atomic. Atomic number, उसको denote करते हैं letter Z से. Okay, is nothing but the number of protons in the atom. So कितने protons हैं? 1. That's why hydrogen is on number 1. Okay, now helium, कितने protons हैं? Number 2. Okay, this is how an helium atom will look. How many protons? That's why it's on number 2 in the list. Number 3. 1, 2, capacity of only 2. Attained its duplet state. Children, it cannot have any more electrons in its state. It's happy. So that's why helium is a noble gas. 2 की capacity है, 2 आ गए हैं. I don't want to give my 2. I don't want anything from anyone else. So I am happy. It will not react. Okay. Hence, helium is a noble gas, and as it has attained duplet state. Okay. Chalo, here we come to lithium. 2 हो गया. Third one will come out, and so on. So this list has to be learnt in order. Number 1 on the chart is hydrogen, helium, lithium has 3 protons, beryllium has 4, boron has 5, carbon has 6, nitrogen 7, oxygen 8, fluorine 9, neon 10. Again, neon is a noble gas. How? Plus 10. It's on 10, so plus 10. 2 electrons, 10 minus 2, 8. Has it not? And this is its outer shell. 1, 2, 3, 4, 5, 6, 7, 8. This is its outermost shell. 10 protons is equal to 10 electrons. Done. Understanding, children? So it does not need outer shell. Outer shell has a capacity of 8. It has got the capacity of 8. Over. I don't need anyone. I don't want to give my electrons to anyone. Hence, it is in its octet state, attained octet state. So, it will not react, and non-reactive elements are known as noble gases. Sodium, 12 magnesium, 13 protons, aluminium has 13, 14 silicon, 15 protons, phosphorus 16 protons, 17 protons. Chlorine, 18. Again, argon is a noble gas. That means non-reactive. 19 potassium and 20 calcium. Children, this list has to be learned by heart. If you want good marks in this subject, in specifically this chapter, you need to know your first 20 elements pit pat in order. Okay, there are a lot of ways, sing-song methods. I have learned it as hi, helly, baby, see, no, for, no, for n, like that. So you can make your own mnemonics. You can make your own poetries and stuff like that to remember your elements. All right, children. This chart not only shows the atomic number or number of protons, it will also show you the symbols. You can't write hydrogen fully every time when you have to show a reaction or how two elements combine. तो इसे छोटे छोटे में convert करते हैं. All right. So these are the symbols. You have to know the symbols as well. Okay, hydrogen H, helium H, lithium, these are still good to go. The first 10 elements are still good to go. They start with their names. The letters are the first letters of the first letter will depict the name of the element. But there are some different ones, like sodium. Sodium is Na. Okay, simply because there may be a lot of elements starting with the letter S, and it can get very, very confusing. So these have these elements have different names in different languages. So in Latin or in Greek, sodium may be given a different name, and hence the first two letters of that Greek or Latin name has been put up. Yeah. So children, this list along with the symbols, very, very important to learn. Okay. This is how your periodic table looks like, children. Okay. See, in the periodic table, hydrogen is written in very small letters. Its font is really small. But however, when I look at the letter H, I know we are talking about hydrogen. The moment I say look at the letter Al, I know it's aluminium. So symbols play a very, very important role to understand your periodic table. So in the periodic table, let me pick up, say, lithium. This one. It says Li. On top it says 3. Bottom it says 6.941. So in the previous chart, we realize that hydrogen, helium, and then lithium. Lithium is the third element. Not only the third, and why have we placed lithium on the third on the list? Why have we placed lithium on third on the list? Simply to tell you that 3 is its atomic number. Atomic number is denoted by the letter Z. So this one on top gives you atomic number which is denoted by Z. So then what is this number? This number is the atomic mass number. This is atomic mass number denoted by the letter A. As the name suggests, atomic mass number. Mass. Mass simply means the number of particles. Yes, number of particles. So atomic mass number. So we just discussed electrons have negligible mass. So the entire mass is in the center of the atom in the nucleus. So what is the mass? What does the nucleus have? It has protons and neutrons. So if I'm talking about atomic mass number, that means I'm talking about protons and neutrons collectively. And Z, which is the atomic number, the number only tells me about the protons, the positively charged. And this gets me atomic mass number tells me both the count, the total of protons and neutrons. So this 6.9, can I round it off to 7? So 7 is the atomic mass number. So if 7, which is the atomic mass number, gives me protons and neutrons, correct? And atomic number, which is 3, gives me only protons. So 7 minus 3, 4. So 4 kya hai? Will it not be the number of neutrons? Yes, children. By this, we can, by these two letters, okay, A and Z, can we not find out the number of neutrons in a shell or in an atom? Yes, children. Take a look. Atomic mass number, which is protons and neutrons collectively, minus the number of protons. Will it not give me the number of protons? Sorry, the number of neutrons? Atomic mass number, which has protons and neutrons collectively, minus Z, which is the atomic number which denotes the number of protons. So atomic mass number minus atomic number gives me the number of neutrons in an atom, in a nucleus. So that gives rise to another aspect or another thing in atoms. Children, till now I had explained that the number of protons is always equal to the number of electrons. But then what is the count of neutrons? How will we know that how many neutrons are present in an atom? Okay, this formula is great to know. But then, ideally, number of protons is equal to number of electrons, which is also equal to the number of neutrons, ideally. Yes? Let's look at carbon. Okay. Now carbon atomic number, I'll delete this. No, let me keep that. So atomic mass number is equal to 12. That means number of protons and neutrons is equal to 12. Okay. That's the atomic mass number. Atomic number is equal to 6. So from here we come to know that the number of neutrons 12 minus 6 hai. Yes, but many a times. Okay, so ideally number of protons is equal to number of electrons is equal to number of neutrons. Correct. But many a times carbon has 7 neutrons or 8 neutrons. It has, most of the carbon atoms have 6 neutrons. But many a times उसके 7 भी होते हैं, 8 भी होते हैं, like that. So what happens to the mass number? So we have 6 protons, correct? And for example, we have 7 neutrons in a carbon atom. कितना हो गया? 13. अरे बट यहाँ तो 12 था, पीरियोडिक टेबल में भी 12 है, बट इट कैन हैपन दैट कार्बन के और वेरिएशंस होते हैं, डिफरेंट टाइप्स ऑफ कार्बन होते हैं. And how do we get to know the different types of carbon? Is depending on the number of neutrons in it. अगर एक एटम के पास different number of neutrons हैं, if an atom has different variables or different number of neutrons, the name of the element remains the same. However, it is depicted or denoted further by the atomic mass number. So agar carbon generally if we are talking about carbon, we are talking about carbon 12. We are talking about carbon 12. But if the carbon atom has 13 as an atomic mass number, we will call it carbon 13. If it has an atomic mass number of 14, we will call it carbon 14. So carbon atom will have variations depending upon the number of neutrons in an atom. Similarly goes with hydrogen also. If you say atomic number and atomic mass number is the same, 1 and 1. That means it has no neutrons, correct? It has no neutrons. However, it can have a neutron. So hydrogen will be depicted by the total atomic mass number. So this is hydrogen 1. We can have hydrogen 2, hydrogen 3, and so on. Okay, we call out the symbol followed by the atomic mass number. And when an atom has different atomic mass numbers, okay, those are known as isotopes. So this is your normal carbon atom. But if we have, so this is my normal, where do I write? I have carbon, which is my normal. If I write only C, it means carbon 12. But if I write carbon 13 and carbon 14, these two are the isotopes of carbon. Simply because carbon has its variations because it has different atomic mass numbers. Alright children, is this much clear? So here we go, children. A little properly done on this slide. Atomic number denoted by the letter Z, tells us how many protons are there in an atom. Number of protons. Atomic mass number denoted by A tells us the mass. Tells us the mass, which is number of protons plus neutrons in an atom. So, number of neutrons will be A minus Z. Yes, children? Okay. Let's look at this chart now. Element H. Tell me, which element is this, children? H will tell me which element. H is hydrogen. Okay. Z tells me the atomic number, which is nothing but number of protons. Yes, children. Okay, number of electrons in the outermost shell. Number of protons is equal to electrons. So अगर one proton है तो one electron होगा. Outer, inner, anywhere. Okay. Number of electrons in the outermost shell only. Okay. Next is C. C is which one? Which element? Carbon. Carbon has six protons. That means 6 electrons. So this is my nucleus. I have 2 in the first shell. I have how many? 6 में से 2 गया 4. 1, 2, 3, 4 in the outermost shell. So how many electrons in the outermost shell, children? 4. Na. What is Na? Sodium. Yes, children. We have sodium. Sodium has how many? Tell me. First shell sodium. सोडियम के फर्स्ट शेल में कितने हैं? 2. 11 है तो 2 गया 9. नेक्स्ट शेल 8. लास्ट शेल 1. 2 plus 8 10. 10 plus 11. So last shell sodium will have 1. Chlorine. Cl is chlorine. Yes, children. For chlorine. Okay, first shell 2, next shell 8. 8 plus 2, 10, bacha 7. Does this give me a total of 17? Yes. So this is your first shell. This is your second shell. This is your third, or we can say third shell, or last shell, or outermost shell. Then we come to N. What is N, children? What is N? N stands for nitrogen. Okay, says 7. So पहले में 2 चले गए, 2 के बाद बच गए 5. So here you go. So this has 5 in its outermost shell. It does not have a third shell. Yes, children? So we just got to know how many capacity कितनी है? 8 की capacity है. However, they have lesser than 8. If they have lesser electrons than 8, it will struggle to get 7 more to become octet. और इसे जाने दे यार, मैं अपना 1 देके 2 शेल में खुश हो जाता. Let me give away this last one. In this one, it is ready to accept 4 or give away 4. Anything is good, but I just want to become stable. I just want to attain an octet state. This one, it's better I give away. कौन ढूंढने जाएगा 7 electrons? I might as well give away 1 and attain octet state. I'll go find for 1 I can find. So here 7 है, it needs 1 more. Here 5 है, it needs 3 more. Now this chart, children, this one that I've just made. Okay, now look at this one. Okay, we know that total number of neutrons is how much? Total number of electrons or protons is how much? 11. So, sodium has 2, 8, 1. So when I write my number of electrons in this form, in the shell form, when I distribute it as per the number of shells, when I write it in this format, 2, 8, 1, let's look at chlorine. 2, 8, 7. When I look at nitrogen, I write it in 2 and 5. This format where you are distributing your electrons as per the shells, this format is known as the electronic configuration of that atom. Alright children, I could have directly written sodium and total number of protons 11, but 11 का मैंने distribution दिखाया है. So when I show the distribution of my electrons, it is known as the electronic configuration of that particular atom. Alright, understood what is electronic configuration? Alright. Now, let's look at this. Okay, I will just erase this. Alright, look at this. It has 1 in its outermost shell. Correct? That means, is it easier for hydrogen atom? See, hydrogen atom has a capacity, has only 1 electron in its outermost shell. Okay, and it has it is in the first shell. First shell में कितने electrons की capacity है? 2 की n square और 2n square के formula के हिसाब से. Okay, hydrogen is first on the chart. Correct, children? So, how many electrons does it need to complete and become satisfied, children? One more. This is a hydrogen atom. So number of protons 1, number of electrons be 1. So first shell में how many electrons does it need to take in? Just 1 more. And it will come into its duplet state as in it will become satisfied, capacity khatam ho jayegi to have any more. Okay, so it needs only 1 more. यहां पर देखते हैं, it can either give away 4. now कार्बन है, कार्बन का 6 है, ये रहे 2, ये 6 है ना, ये है 2, बाकी के बचे 4, 1, 2, 3, 4. and second shell, outermost shell, capacity is 8. 4 है, या तो ये अपने 4 दे दे and become satisfied with 1 shell in duplet state, or it acquires 4 more and attains octet state and stable हो जाए, non-reactive हो जाए. Correct? So let me say it needs 4. It will either donate 4 or either ready to accept 4 to become stable. Okay, sodium last shell में 1 है. Is it easier to give away 1 or accept 7? Easier to give away 1. Let me write this. Easier to give away 7 or accept 1? Easier to accept 1. Easier to give away 5 or accept 3? Easier to accept 3. So, the ability of an atom to donate, accept, or share electrons. Okay, here ability of an atom to donate. It can either donate, ये जो 1 है वो दे दे या फिर accept कर ले 1, तो इसकी ये कैपेसिटी है. यहां पर ये either 4 दे दे या 4 accept कर ले, उसकी कैपेसिटी है. Anything. यहां पर it's not possible. It's not that it's not possible. It becomes very hectic for this atom to go find 7 different atoms और उनसे एक ले. So it is better that it donates this one. Here also, here 7 already है, एक accept कर लूं, ले आऊं किसी से. यहां पर 5 देने के बदले में 3 ले आऊं to attain octet to become 8. So this is either the ability of the atom to donate, accept, or share electrons. Correct or no, children? So the ability of an atom to donate, accept, or share electrons is known as the valency of that atom. The ability to donate, accept, और share electrons. Okay, या तो मैं दे दूं, कितने दे सकता हूं? यहां पर मैं 1 दे सकता हूं. और accept, कितने ले सकता हूं? 1 ले सकता हूं. और to share, चलेगा? Share, you want to take mine or I'll take your, anything is good. Okay, is known as the ability, is known as its valency. And valency हमेशा वैलेंट शेल से ही होगी, अंदर की नहीं होगी. अंदर के इलेक्ट्रॉन्स नहीं, सिर्फ आउटर मोस्ट शेल की कैपेसिटी कितना देना कितना लेना. ओके, सो दैट्स नोन एज द वैलेंट शेल. एंड जो इलेक्ट्रॉन्स जो अदला बदली होते, ये जो इलेक्ट्रॉन्स का देना लेना होगा, दोज इलेक्ट्रॉन्स आर नोन एज वैलेंट इलेक्ट्रॉन्स. Yes, children, do we understand? All right. Let's understand this chart, or let's fill up this chart. Chaliye. Let me check this. Okay. All right. Hydrogen first in the list. Okay. Only one electron as per electronic configuration. First shell में सिर्फ एक electron. Helium 2 attained octet state, done. Lithium 3 है, so first shell में 2 आएंगे, second shell में 1 आएगा. That's how electronic configuration. Carbon, there are 6. First shell 2, 6 में से 2 गया, next one 4. So what's the electronic configuration? 2 and 4. Nitrogen 7. First shell 2, 7 minus 2 5, capacity of 8, 5 चल जाएगा. Oxygen 2, 8 minus 2 6, electronic configuration 2 and 6, 9, first one 2 and 7, 2 and 8, 8 हो गया, ऑक्टेट स्टेट आ गया, 8 से ज्यादा की कैपेसिटी नहीं है, that's why it is a noble gas. This is also a noble gas, non-reactive. This is also a noble gas. Simply जितना चाहिए था उतना उनके शेल में, ऑर्बिट में है. सोडियम 2, 8, 2 plus 8 10 और एक और 11 है ना, 2 plus 8 10, 10 plus 1 11. So इलेक्ट्रॉनिक कॉन्फ़िगरेशन के हिसाब से इलेक्ट्रॉन्स का डिस्ट्रीब्यूशन देखो, 2 and 8 10, 7 2 8 7. Argon 2 8 10 and another 8 18. Again last shell में 8 आ गया, last shell में 8 आ गया. Okay, this is also a noble gas. And 2 8 8. Here bromine 35. So first shell 2, second shell 8. 10 हो गए, 35 में से 10 गए, 25. थर्ड शेल कैपेसिटी 18. कितना बचा? 25. एटीन पूरे आ जाएंगे? नहीं. $35 minus 2, 33, 33, 35 minus 2, 33, 33 minus 8, 25, 25 और इसकी कैपेसिटी है 18. 25 minus 18, how many? What is wrong with me? 25 cells में से 18 minus हुए 9 10, okay, 1 9 10 11 12 13 14 15. So इसमें 18 and 7. So 2, 8, 18 and 7. 2, 8, 18, 7. This is the electronic configuration of bromine. Just check, children. Good to go? Understood electronic configuration? Understanding the distribution of atoms, understanding that 2n square के हिसाब से every shell is being filled with electrons. चलो, valent electrons and valency, we just spoke about it. Let's elaborate or let's go through it. Okay, what are valent electrons? The number of electrons in the outermost shell, सबसे बाहर वाले shell में जहां पर donation and acceptance होता है, उसको वो वाले electrons को हम बोलते हैं valent electrons. What is valency? The valency is the capacity or ability of an atom to accept, donate or share its valent. Last के shell में जितने भी electrons हैं, ओके, या तो वो डोनेट कर सकता है या एक्सेप्ट कर सकता है या शेयर कर सकता है टू अटेन स्टेबिलिटी. 8 बनाना है उसको, अगर 8 बनाने के लिए एक दे देना है और उससे पहले वाला ऑर्बिट 8 बन जाता है, इट विल गिव अवे, इट विल डोनेट. सो इट हैज द एबिलिटी टू डोनेट इफ इट इज लेसर देन 4. If any electron, if any atom has less than 4 electrons in the outermost shell, what will it do? It will donate. It is easier to donate. If it has, say, equal to 4, it will share. If it has more than 4 electrons in its outermost shell, it will accept. So your valency cannot be more than 4. We will find out, we will work this out in this chart. Okay, so valency is the capacity of an atom to accept, donate or share its valent electrons with other atoms. Molecules कैसे बनते हैं? Bonds कैसे बनते हैं? आदान प्रदान करके, एक दूसरे के साथ शेयरिंग या एक दूसरे को दे के या उनसे एक्सेप्ट करके. ओके, चलिए, नंबर ऑफ इलेक्ट्रॉन्स कितने हैं? 3 हैं. इसका इलेक्ट्रॉनिक कॉन्फ़िगरेशन कितना होगा? फर्स्ट शेल में 2, सेकंड शेल में 1. नंबर ऑफ वेलेंट इलेक्ट्रॉन्स मतलब 1 है. एक देना आसान की 7 एक्सेप्ट करना आसान, एक देना आसान. सो नंबर ऑफ valent electrons means number of electrons in the outermost shell. So it's easy to give away 1, so its valency becomes 1. Carbon electronic configuration, 2 in the first shell, 4 in the second one. So is it easy to accept? How many electrons in the valence shell? 4. Easy to accept or to donate or to share, all is good with carbon. So its valency is 4. Let's look at magnesium. 2, 8 and 2. 2 plus 8, 10. 10 plus 2, 12. Correct? 2. Less than 4 तो दे देगा, डोनेट कर देगा. So number of electrons, 2 in the outermost shell. Happy to give away, rather to accept 6. So 2 is the valency. 8. 2 हो गया, 6, आउटर मोस्ट शेल में कितने हैं? 6। अब 2 लेना आसान की 6 दे देना आसान? 2 लेना आसान, so its valency is 2. Children, are we understanding this table? Here, children, we have a short note about isotopes. Remember, I spoke to you about isotopes, and isotope is the different variation of a particular atom. Carbon 12, carbon 13, carbon 14. अगर उनमें अलग अलग कार्बन कभी कभी 6 न्यूट्रॉन्स के साथ आता है, कार्बन कभी कभी 7 न्यूट्रॉन्स के साथ आता है, कभी कभी 8 न्यूट्रॉन्स के साथ। कॉमनली वाला कौन सा है? 12, मास नंबर 12। ओके, कार्बन 13 एंड कार्बन 14 कभी कभी अवेलेबल है, तो उनको क्या नाम देंगे? द वेरिएशन ऑफ कार्बन 12, कार्बन 13 एंड कार्बन 14 को क्या नाम देंगे? हम आइसोटोप्स कहेंगे चिल्ड्रन। Okay, so we will elaborate on that. However, what are the uses of isotopes? Isotopes of some elements are radioactive. Radioactive means giving out radiations. Some isotopes give out radiations. Okay, they are used in various fields such as industry, agriculture, medicine, research field. Look at this one, uranium 235. यूरेनियम 235, 235 क्या है? मतलब एक वेरिएशन है। यूरेनियम अलग एटॉमिक मास नंबर से ज्यादा पॉपुलर है, बट एक और ऐसा यूरेनियम का टाइप ऑफ एटम है जो यूरेनियम 235 बोला जाता है, विच इज एन आइसोटोप, इज यूज्ड फॉर न्यूक्लियर फिजन एंड प्रोडक्शन ऑफ इलेक्ट्रिसिटी। फिजन का मतलब होता है तोड़ना, फिशन मतलब तोड़ना, अलग करना। सो न्यूक्लियर फिशन के लिए क्या काम आता है? यूरेनियम 235. Some radioactive isotopes, some isotopes which give out radiations like cobalt, okay, like cobalt 60 are used in the medical treatment of fatal diseases like cancer. Radiations देने जाते हैं सेल्स को, रेडिएशन से, जो कैंसर के सेल्स होते हैं उनको रेडिएशन से खत्म करते हैं। कौन से रेडिएशन होते हैं? कोबाल्ट 60. Iodine 131 is used in the treatment of goiter. Goiter is a deficiency of iodine. तो iodine की deficiency किससे क्योर करते हैं? iodine 131 से, and diseases of thyroid gland. Deficiency of iodine है goiter and thyroid. The radioactive isotopes are used for detection of cracks or leakages in the underground pipes, etc. Example, sodium 24. अगर लीकेज है या क्रैक्स है तो उसमें से रेडिएशन निकलेंगे। पानी में हो सकता है थोड़ा सोडियम, आई एम नॉट श्योर अबाउट बट अगर पानी में थोड़ा सा रेडियम डाल दिया, थोड़ा सा सोडियम डाल दिया, एंड वैसे तो एक पाइप से गुजरेगा तो कहीं से लाइट नहीं आएगी, रेडियो एक्टिव है, लाइट नहीं आएगी, रेडिएशंस नहीं आएंगे, बट लीकेज होगा तो उस एरिया से लाइट निकलेगी। सो टू डिटेक्शन ऑफ leakages in pipes, radioactive isotopes are used for food preservations from microbes. तो ये radioactive isotopes क्या करते हैं? माइक्रो ऑर्गेनिजम्स, बैक्टीरिया, फंगाई जो फूड के ऊपर ग्रो होती है उनको किल करने में भी काम आते हैं। The radioactive isotope carbon 14 is used for determining the age of archaeological objects. एक पर्टिकुलर मॉन्यूमेंट, एक पर्टिकुलर रेलिक कितना पुराना है, एक पर्टिकुलर स्टैचू कितना पुराना है, किससे पता चलता है? कार्बन 14, और उस प्रोसेस को बोलते हैं कार्बन डेटिंग। वो एक चीज कितनी पुरानी है ये वो बताता है। एंड सी रेडियो एक्टिव आइसोटोप कार्बन 14 बताता है। सो नाइस, लेट्स रीड दिस नाउ। न्यूक्लियर रिएक्टर्स, Nuclear reactor is a machine that generates electricity on large scale. Okay, what is a nuclear reactor? It's a machine that generates electricity on a large scale by using atomic energy. Okay, in a nuclear reactor, the nuclear energy in atoms, atom के अंदर की जो nucleus है, वो nucleus की energy को is released by bringing out nuclear reactions on the nuclear fuel. Reactions करता है. Let us understand a nuclear reaction with example of a nuclear fuel, namely uranium 235. चलिए uranium 235 का reaction पढ़ते हैं, nuclear reaction पढ़ते हैं. On bombardment with slow speed of neutrons, slowly बहुत सारे न्यूट्रॉन्स बम्बार्ड किए जाते हैं. The nucleus of the isotope uranium undergoes nuclear fission. So जब न्यूक्लियस के ऊपर यूरेनियम 235 के न्यूट्रॉन्स बम्बार्ड किए जाते हैं, ओके, उसका क्या होता है? इट अकर्स न्यूक्लियर फिशन, वो टूट जाता है उसका न्यूक्लियस, ठीक है, टू फॉर्म न्यूक्लियाई ऑफ टू डिफरेंट एलिमेंट्स. तो वो टूटता है और यूरेनियम क्या बन जाता है? क्रिप्टॉन 92 एंड बेरियम 141. ये कैसे बनते हैं? यूरेनियम 235 and it undergoes a fission, breakage, and 2 to 3 neutrons. On decreasing the speed, these neutrons bring about fission of nuclei. जब ये इनकी और स्पीड घटाते हैं, कम करते हैं, it goes through fission of more uranium 235 nuclei. In this way, a chain reaction of nuclear fission takes place. A large amount of nuclear energy is released. जब मैं बोला ना आसान नहीं न्यूक्लियस तोड़ना, जब न्यूक्लियस टूटता है बहुत सारी एनर्जी निकलती है, बहुत सारा nuclear energy is released and a chain of reaction of fissions. अब ये जो 2 to 3 ये तो 2 में डिवाइड हो गया और 2 to 3 न्यूट्रॉन्स बच गए, वो फिर से दूसरे यूरेनियम 235 को अटैक करते हैं, वो टूटता है, फिर उसके ऐसे करते करते जो 2-3 है वो अगले एटम्स को तोड़ते जाते हैं. The chain reaction is kept under control to prevent the probable explosion. इतना टूटेंगे तो एक्सप्लोजन हो सकता है. Here, normally these centers, children, कुछ भी मिसहैप होता है इसलिए सिटी से या पॉपुलेटेड एरिया से दूर बनाए जाते हैं ऐसे सेंटर्स. सो न्यूक्लियर रिएक्टर बाबा एटॉमिक रिसर्च सेंटर इन मुंबई. दिस इज हाउ इट लुक्स. Here, see, to control the chain reaction in the nuclear reactor, it is necessary to decrease the speed and number of neutrons. वो 2-3 से barely 1 या 0 पे लाना पड़ता है. For this purpose, the following provision is made in a nuclear reactor. So here you go, एक न्यूट्रॉन आ गया, एक न्यूट्रॉन ने बम्बार्ड किया यूरेनियम 235 को, ये बन गए 2 क्रिप्टॉन एंड which one was the other one? क्रिप्टॉन एंड बेरियम में डिवाइड हो गए, फिर इसका निकला, here we got krypton, here we are, and 2-3 न्यूट्रॉन्स फिर आए. अब ये दूसरे यूरेनियम एटम को अटैक करेगी, फिर वो डिवाइड होगा क्रिप्टॉन एंड बेरियम में, फिर 2-3 न्यूट्रॉन्स आगे जाएंगे, फिर क्रिप्टॉन बेरियम, एंड दिस इज अ कंटिन्यूअस चेन of disintegration of uranium 235. Okay, now what is a moderator? What is the use of moderator? Is something which reduces the speed of the reaction. Okay, speed of the neutron hitting another uranium 235. So graphite or heavy water is used as a moderator for reducing the speed of neutrons. जितनी जोर से, जितना फास्ट न्यूट्रॉन हिट करेगा यूरेनियम 235 को, उतनी जल्दी जल्दी नए न्यूट्रॉन्स प्रोड्यूस होंगे और नए यूरेनियम 235 को अटैक करेंगे, बम्बार्ड करेंगे. What is a controller? It is used to reduce the number of neutrons by absorbing them. Rods of boron, cadmium, beryllium, etc. are used as controller. तो ये जो है इनके न्यूट्रॉन्स को ये तीन एलिमेंट्स अब्सॉर्ब ही कर लेते हैं, ताकि वो होगा नहीं तो बम्बार्ड क्या होगा. During this fission, when the nucleus breaks, heat is produced. In the heat produced in the fission process is taken out by using water as coolant. तो वाटर यूज किया जाता है उस हीट को कम करने के लिए. द वाटर इज ट्रांसफॉर्म्ड इनटू स्टीम. ओके, बाय मींस ऑफ दिस स्टीम टर्बाइन्स आर ड्रिवन. ये इलेक्ट्रिसिटी कैसे प्रोड्यूस हो रही है? जो हीट प्रोड्यूस होती है उसको कम करते हैं और रादर इसको ऐसे स्टेट में लाते हैं जहां पर वो स्टीम बनती है और स्टीम छोड़ी जाती है टर्बाइन्स पे. टर्बाइन्स, विंड मिल्स, टर्बाइन्स. ओके, जब वो हिलती हैं एक स्पीड पे, फिर वो टर्बाइन्स इलेक्ट्रिसिटी बनाती हैं. By means of steam, turbines are driven and electricity is generated. In India, total 22 nuclear reactors in 8 places are functioning. Apsara at Bhabha Atomic Research Center in Mumbai is the first nuclear reactor in India which went critical on 4th August 1956. India has large reserves of the element thorium. Therefore, Indian scientists have developed a future plan for nuclear reactors based on production of isotope uranium 233 from thorium 232. सो पाइपलाइन में और सोचते सोचते करते करते चीजें एग्जॉस्ट हो जाती हैं. सो नई चीजें चाहिए होती है जो आपका फंक्शनिंग, आपका इलेक्ट्रिसिटी सप्लाई, आपकी चीजें सप्लाई कंटिन्यू करने के लिए न्यू इन्वेंशंस करते रहते हैं. Alright children, so this is the end of our chapter. Hope you've understood everything properly. Please go through your school notes and prepare for your test. Thank you. God bless.